Very good. Well, folks, without any further delay here, W1ASS Paul has graciously agreed to talk about the beast on the hill, the fort repeater. Go right ahead, Paul. Thanks so much.
Is it on? I have to put my glasses on. Let's see. Okay, get ready here. I think I'm going to sit. Makes it easier. In case you don't know, I may start coughing. I have respiratory issues, so every once in a while I'll be drinking and stuff. Um, so Fort Mountain, some people think it's a mystery, whatever. It's not really that much of a mystery. That's actually the equipment shelter, TV station, and the tower. So get going here. Um, hopefully this is going to work. Is it plugged in? There? No. Just, it worked before. Nothing. Oh, it worked. Hmm. Okay. So let's make sure it works. Okay. So basically, these are some of the things I'm going to try to cover. Not that you really care about my background, but I'm going to give it anyhow. Um, what's my background? I don't really have any accomplishments. Fort Mountain, I don't know. There's really not that much, but I'm going to give you my history. So, when I was grammar school, my father was going. He was in the military. He was retiring. He went to a TV repair shop to learn how to repair TVs. Brought home lots of electronic stuff, and I actually got into electronics that way, but wasn't thinking about it. I was going to be an electrician, woe be it. Had no interest in ham radio at the time, so class radio operator's license and radar endorsement. Basically, when I was 18 years old, that's when I started getting into radio. And of course, it's probably not going to work. Is it that bad? Go ahead. So I ended up, and I was going to college, and I went to Channel 9, started working there, and I actually ended up dropping out. Go ahead. um, next one. Yeah. Um, ended up leaving broadcasting, ended up going into industrial electronics, worked for Raytheon as a field engineer, which was all R. Um, after that, I decided to go back into engineering because the industrial electronics started failing, the economy started going down, TV was still working. So I went there. Shortly afterwards, I became the chief engineer and ended up quitting. During that time that I quit, that's actually the time that I started getting interested in putting up a repeater. When I was chief engineer at Channel 50, I actually went to the LRL Ham Fest in Manchester. Just decided to take my test. I hadn't studied for it. I took the tech, got that, went ahead, took the general, got that, but I couldn't do code. So I left it at that till I could turn around and actually get my code. Um, so during that time that I was unemployed, I was actually building the second version of Fort Mountain, which I will show later. It was home built, and it's totally built from scratch. Are you advancing it? Okay, good. Okay, I'll go like that. Okay, so ended up over Channel 5, did that the scratching, then I moved on to Channel 11, which actually I had big dreams of having repeaters all around the state because the tower sites everywhere. Little did I know, Department of Economic Resources actually oversaw most of those locations, which ruined my whole dream of that. So I stayed with Fort Mountain. Um, Same time while I was doing that, became senior director of engineering, and decided I wanted to turn around and actually build a commercial radio station. So I ended up, nobody knows about it, but I actually built from the ground up, designed it. 94.7 WQNH. You would have heard my voice on it. I did all the announcing. Next. Um, During that time, COVID came along. I ended up getting COVID. I was bedridden for about 4 months, and eventually ended up going back to work. I ended up discovering that I didn't remember everything that I used to remember. So on this, I'm not going to remember everything either. So I'm not going to remember everything. So we're just going to go over some basic stuff. Some people may know all of this stuff already. Others may not know. So we'll go. So this is actually the cabinet. I had big plans up there of having a little bit more than I have now, but it's virtually impossible to do anything up there. I'm limited to one antenna, one line, one cabinet, and that's it. So we'll quickly go over all the pieces of a repeater. So basically, repeaters simply, well, for ease, two mobile radios. They're interconnected to each other. You got your receiver. It's receiving one frequency. We'll say 5 megahertz apart. You got your transmitter transmitting 5 megahertz above or below, whichever the case be. And simply, it's the receiver's audio out going over to the transmitter's audio in. Simple as that. There's a controller, but I'm being basic on this. Um, so in order, at first on there, it showed two antennas apart. You could do that as a repeater. But the problem is space limitations to get the proper separation to reject the transmitter would be too much. So you end up putting a duplexer in so you can use one antenna. To control those two mobiles, you're going to need a controller. It's going to take the audio from the receiver over to the transmitter. And why I did that in yellow, I'll never know, but it basically keys up the transmitter, gives you some level adjustments so that you don't exceed the deviation. And you got to do your call sign, whether it's voice or Morse code. It's providing that. And in that, that controller is a very, go back. Okay, that controller is a very advanced controller. It actually allows you to have up to 3 repeaters on it. You can use it for linking to other repeaters. You can turn around, control a 440, a 220, and a 2-meter repeater. They can all talk to each other. You can do whatever you want to do with it. It's very simple, but of course it costs money. Or you can do something with a little board like this using a PIC chip, and it will simply it's got some audio level adjustments, Morse code ID, no voice. You can do timeout, timer, very basic, and very cheap. I think that's about $30 versus probably when you buy the cabinet and everything, over $300 for that one. Okay. Yeah, joke. So cables, we all know what cables are already. We have them hooked up to our antennas. Of course, in my house, I have tons of network cables. I have less RF cables than network cables. You can go ahead. Antennas, everybody knows what those are. They come in all different shapes and sizes, things like that. This is actually the top of Fort Mountain. You can't actually see it, but over here, that's a Yagi, but because of the ice up there, they actually have to put it in a radome. All the parabolic dishes, they actually have covers over the front of them. That's also to keep the ice off of it due to the conditions on top of the mountain. Fort Mountain is not favorable in the wintertime. So go ahead. So we'll go ahead and talk about Fort. Is there a secret sauce? Yes and no. Mainly it's got to do with a lot of the components that are used in the repeater system, and of course the location helps. You can have the absolute best location out there. If you don't have a good antenna, it isn't going to work. If you don't have the proper equipment, it's not going to work. And I know because I started out with the cheapest equipment originally. I don't have the repeater here to show, but I started out with a amateur whip, basic two mobiles and a controller. It didn't work very well. I upgraded to a Cushcraft dipole, stack dipole. It worked a little bit better. Still didn't work well. Went to a Comet, a diamond antenna. I actually burned up a diamond dual band antenna because I thought I was going to be able, with one antenna, be able to have a 2-meter and a 440 repeater. But the antenna just burned up, so I trashed that. Okay. This is the actual antenna that's on Fort Mountain. When I bought it, it did not cost $2,199. I will say it did cost about $800 and something wholesale. It was a $1,200 antenna. It has 10 dB gain. That's actual gain, not over isotropic. It's got a 12.15 dBi gain. That's basically in free space, we'll call it. It's based against a radiator that radiates in all directions with no gain whatsoever. It's got a 500 watt rating. It's 20 is the key things. 500 watts. It's 21 feet long and length. It weighs 25 pounds. Any of your amateur antennas, you can sit there with a whip antenna, you can hold it. Go ahead. The best amateur, we'll say, whip antenna. It's a little bit heavier, but it only weighs 5 pounds. I've never actually seen this antenna, so I can't speak for it, but quite frankly, I don't think it would survive on top of Fort Mountain. With the ice that's up there, the winds and things like that, and also the other antenna is 21 feet. This one's 7 feet long. I'm not really sure because the gain is made by stacking dipoles on top of each other, and so as the gain goes up, a lot more dipoles. So being at 7 feet, did they do quarter wave? I don't know how they did it inside. So I kind of sit there and say, I don't know if it would work very well. Go ahead. We can step down to the even cheaper one, which is basically something like I tried. It's got 6.9 dBd gain. But now that one's down to 3 feet, and quite frankly, with the wind up there, I don't know exactly how it would survive. So I wouldn't recommend anybody doing a repeater. Don't buy any cheap antennas. I would buy at least a Hustler or something in that ground. Something that I did not put here is a stacked folded dipole. Folded dipoles work very well. The problem is to get to the gain that I'm running, being 9 dB or whatever, it would require a lot of stacking. So a folded dipole, every element is exposed, and it would be 20 feet long, basically, and it would be a massive magnet for ice buildup, because every single folded element is going to turn around and start building ice, and as it builds up, it's going to fill in. Once it fills in, it becomes a giant wind sail. And along with the phasing harness that's going up the aluminum pipe. Yeah, it's an aluminum pipe, but now you're going to get your high winds. Will it survive? I don't know. I've seen too many folded dipoles actually fold over. Next one. So basically, so on this, as you increase your gain, you may already know this, you may not know it, I don't know. So when you have very low gain, you get a nice fat lobe. So what I'm trying to show here is basically it's down near the ground, it's high up into the sky. As you increase your gain, you start squeezing all your power in. But notice that it's no longer along this line here. So we're getting further away from this house. Still not a problem. This view, if you were looking down from the top, would be a donut with a hole in the middle where the antenna is, we'll call it. Just a tiny little speck of a hole. And then a 360-degree of this type thing. This is just a slice, a half of the, you're looking sideways at the donut. If you add the 9 dB here, you're pushing it really far out, but now it's getting narrow. And one of the problems, and I'm going to actually show, so it's really hard to show it in this screen. So I'm just going to use the flashlight. Light is RF. Our eyes are the antennas. They actually see the light. Happens to be the frequency of the light. So a low gain antenna. You notice it's just all up there. And as we start to increase the gain of the antenna, our lobe starts coming in, but we start forming in the center a brighter center. And as we increase the gain of the antenna, we actually now have what you're seeing here. Okay, so you're going from being a broad pattern here to a very narrow pattern here. Now, it's great, and as you see, if we go close up, I don't know if everybody can see it, but close up, that beam is very small. As we go further away, down here, that bright circle gets bigger and bigger. The further you go, the bigger it gets. Okay, so as it's going out, it's going to turn around and actually expand out, but all your energy is mainly in the center, and lots of it is just spilling off on there. So that's just to show you what happens to an antenna pattern. Okay, next. This is, so I'm sitting here running a 50-watt repeater. And by adding gain to the antenna, I can actually get extra range out of it. So with a 3 dB gain antenna, basically, it's not exact, but for ease, a 3 dB increase, you double your power. So we're starting with a 50-watt repeater. We add a 3 dB gain antenna. We get the effective radiated power of 100 watts. We put a 6 dB gain antenna. We're going to get the effective radiated power of 200 watts. 9 dB, 400. Every time you double your power, 100, 200, 400, you're going to get 3 dB more in signal. We can go to the next one. So I had a reader, and in this case, I have to have a reference. So I'm just going to use 50 watts as my 0 dB reference. And I'm going to use a 3 dB antenna. And with 50 watts, we're going to say there's no coverage whatsoever, 0 coverage. So I'm going to double my power to 100 watts. This is how far my 100 watts is going to go out. But I got this nice broad pattern because it's I'm going to call it a 3 dB or 0 dB gain antenna. I got a nice broad pattern. If I turn around and at my repeater, I increase the power, the tubes push it out into this, but my pattern is going to be much broader because I'm not squeezing the power down, I'm pushing the power out. If I increase my repeater to 400 watts, I'm going to push that power all the way out to that point with a nice broad pattern. So on basically, we'll go to the next one and then I think it probably makes more sense. So something people talk about is, oh, there's something wrong with the repeater. The signal's varying. It's going up, it's going down, it's going up, it's going down. So because I'm using a 9 dB gain antenna, I have this very narrow pattern, and I cannot remember when I actually ordered the antenna, and unfortunately I cannot remember if I did something called negative beam tilt, and that's to bring that pattern from being out straight down a little bit lower. If I had a positive beam tilt, I'd be sending it up to space. I don't need to do that. I want to serve everybody on the ground. So you can go ahead and advance one. So the wind blows. the antenna moves. So in this case, the antenna is moving back. I've now concentrated my power with a positive beam tilt. I'm sending it up. So this guy here that's close in, whether it be, so with the 9 dB gain antenna, that little narrow pattern, it's got small amount of RF going downward. He's really not going to notice the fact that that antenna went up or down or anything. This guy is going to notice it more because now the signal's been pulled up. If it was marginal to begin with, he's going to turn around and really notice it. This guy's going to even notice it even more. The guy way down on over here, there's nobody there, but if you were over there on the other side of the hill, um, probably wouldn't notice it because of the RF going downward. Go ahead. So now we get the wind blows the other way, or the antenna, because it got pushed backwards, is now through elasticity of the fiberglass wanting it to go back, it overcorrects and shoots down. Now we've turned around and pushed all that power downward. This guy's getting a fantastic signal. The guy over here may not get it because all the power is being put down here, depending on how far down and how much. It's more likely that that would be shadowed by that hill. So next. Why is it so? That's weird. It doesn't show in that one as much of what. Um, no, that's it. Okay. Well, go back to that. It's going to play the video. Maybe not. So 21-foot antenna, 10-foot schedule 40 pipe, I believe, mounted on one of the ice bridge posts. That antenna is taking a beating, being whipped back and forth. If the video had showed, not sure why, but it was weird. I even noticed the funny thing that it actually went into an oscillation after it had done a couple whips back and forth, and then there was this weird oscillation up and down it. That antenna normally would be mounted on the side of a tower, and there'd be a stiff arm, which is basically fiberglass. It would not affect the pattern. It would be coming from a tower leg to the upper portion, holding it straight as can be. So in those wind or ice conditions, not going to do anything. Unfortunately, I can't go on the tower. I was offered to go to the top of the tower, 300 feet or whatever it is, which it would work even better, but I would have to pay the tower crew to do that. A day's labor in the tower crew is about $4,000 and something on the crew that does it. So if it breaks, I have to call them. So, and I'm really not even allowed to go up on the ice bridge anymore, they tell me, but I put that antenna up myself, but what they don't know, if there's no cameras, it's it. Go ahead. Okay. So a lot of times people are, they hear the repeater, but they're, they can't seem to bring it up. Basically, the handheld is only 5 watts or 1 watt or whatever, and the repeater is putting out, I'm just going to say 100 watts into a 9 dB gain antenna. The 9 dB gain antenna helps out for picking up the signal because there's all those light, weak signals coming in. It gets focused back down same way, just opposite way. It will help the receive. But it's just not that good next. So recently, last year, I decided to throw in, I normally did this, but I just hadn't done it. So last year I threw in an advanced receiver research gas FET preamp. What does it do? It helps some of the signals. This is a twofold thing, and I'm not really sure if it's the gas FET or what. There's a little popcorn sound. You hear a little pop, pop, pop. If somebody has a good signal in there, you never hear it. But if you're a weak signal or medium signal, there's this occasional pop, like a little sound of a popcorn popping. I'm suspecting it's white noise being generated in the gas fed amplifier, and I'm not sure if it's just a fact of life. I'd have to change the amplifier to find out. I do have another one, but I say, just leave it alone for now. It gives you 18 dB gain in signal. So what did it do? It actually turned around, and those weak handhelds or those weak mobiles, it was actually able to bring it up a little bit. It doesn't perform miracles. If there's nothing there, it's not going to bring nothing in either way. If the noise level, if it's so weak down there, it's just not going to be able to get enough amplification. The amplification is based, that 18 dB gain is based upon a certain signal level coming in, and you're not going to get that in the normal case. Go ahead. 2 years ago, Doug threw in a additional bandpass filter to help reject some of the transmitter noise or possibly some interference. The problem was the duplexer was actually not in good shape. So that may have been just adding some lipstick to a problem that existed. I don't know, but I put after that actually before that bandpass filter, I threw in the gas FET preamp and then let the bandpass filter out anything that might have been outside of the receive frequency. Go ahead. I started out with a 4-cavity duplexer. It's okay. The problem is you don't get as much rejection between the transmit and the receive frequency. Because it's only 2 cavities, the signal that comes in from the receive, you don't have as much attenuation. So you're able to pass on a stronger signal to the receiver, which the receiver is able to reproduce a little bit better. But the problem is your transmitter, if you increase your power, there's a point that the rejection between the receive and the transmit isn't good enough, and you start to get some desensing going on. And desensing is when the front end is being overloaded by another signal, but it's not actually decoding it, I believe would be it. Go ahead. So later I invested in a 6-cavity duplexer that did a huge improvement on how the system worked. And plus this brand, which is a cell wave, in this case, that's a Philips Dodge, I believe. These actually, you actually have, so these slugs here, you tune them to pass the frequency. And so over here on the transmit side, you would pass the transmit frequency, and then you would turn around, and whatever the receive frequency is, there's little on the back sides of these coax connections, there's a screw connection. That's a reject. And what you do is tune that for maximum reject. So what it does, I would tune this for maximum reject of the receiver so that I'm not loading down the receive side. It's making it look like it's not even there. And on the transmit side, you reject the transmit. Same way, trying to get those two signals separated as much as possible. So this is the actual setup. That's actually a paging cabinet that a paging company pulled out of one of the NHPBS sites. And so I grabbed it, thinking that, oh, I was going to have a 2-meter repeater in there also, and had room for an amplifier. And plus, if you could go to a 2-meter duplexer, they're going to take up almost all that cabinet. That's if you can fit it in there. Next one. Um, 10-watt amplifier, digital and analog. If you want to do P25, it's mixed mode. You can go into it with P25. No, it doesn't do DMR, it doesn't do any fusion and all those other digital services. Okay, next. This is basically the backside. Because the repeaters use so much, the cabinet actually gets very warm. And because it was a paging transmitter, there was actually this many fans. Over time, I think I'm down to 2 working fans. I might have put a third one I had in recently last year, I think, to help cool it because it was a little warm in there. Next one. So that's a close-up of the back side. This is the old duplexer as a Philips Dodge. You can see the gas fed preamp. This is the bandpass filter. This little guy right here with the green light, that is the remote control board that allows the repeater to be shut down remotely. As soon as it hears a DTMF tone, it says, well, I don't want to retransmit DTMF tones because that's going to tell everybody what my codes are. Music. Unfortunate reason, every once in a while, somebody, especially Anthony, um, every time I heard him raise his voice, and then Ralph raised his voice, and all of a sudden the repeater goes silent. What's happening is it's muting the audio path in the repeater. And then when they unkey, it sends out a little beep boop. And that's saying it's releasing the DTMF muting mode. Unfortunately, to be able to control the repeater remotely, it's an idiosyncrasy. I researched about voice over IP phone systems, about DTMF and false triggering of DTMF, and I found that it does happen. Supposedly, you cannot duplicate with your voice a DTMF tone. I don't know why, but I read it happens, and people are on long distance phone calls, and somebody says something a certain way, and the call drops, thinking that they hung up for some reason. Okay. So that's back when I had the time to build an actual repeater. This was hand built. I had gotten some metal, mobile amplifier, and I actually built a repeater that I thought was what was necessary. And in that previous one of all the network cables and all the blinky lights, I love lights. So when the amp's on, the fans are on, the receiver's on, the transmitter's on, is there an over temp? Is it on? Is it busy? Is the transmitter transmitting? I like to see all those lights. They give me a lot of, it tells me what's going on. I also added the fact of if I wanted to key it up right there, I could throw the switch down. If I want to make it open, I could just turn the PL off and any carrier could come in and key it up. And I could turn off the repeater function because it's a mobile. The receiver's over here. So I brought the volume and squelch out, and over here on the transmitter, I brought the microphone cable out on the front. The microphone jack on the front. Next. That's the actual top of the repeater that I built. I had a little time. It's not the neatest thing, but considering as many circuits and things, all the LED wiring stuff, this is actually housing a fan delay. These blowers on after you off so that this is a 100-watt mobile amplifier. You should never use a mobile amplifier on a repeater in theory, but if you can cool it, it's really no different because a base station amplifier, the only difference is it's got a massive heat sink on it versus a small sink. A mobile, you don't have the room in the vehicle, so you have a small heat sink. But if you put the cooling fans on it and run them, it works. That survived many, many, many years and long conversations. It used to be busy in the morning commutes, evening commutes, a certain group of people. I also had the receive preamp put in on there. I had a problem because these are DC fans. They're being switched. Can't have that. I feel like Alfred Trillian on channel 60. His mic fell off. Cold weather did it. So because they're DC, there's a it's really electronic in how they're rotating it. They're brushless fans, so it has to be done electronically. So I ended up with getting noise back into the audio through the DC power supply. So I ended up putting a simple alternator filter in there to just take that out. It just totally removed it. The filter removed everything. So, okay, next. So some things some people have heard me talking about is simulcast. Will that ever happen? I don't know. Simulcast is a great thing. When I was at Channel 11, um, I proposed to the FCC. I was trying to convince people that when they were doing the rechannelization, they didn't know where to move everybody. Well, the beauty of simulcast is, and I'll use channel 11 as an example, they had channel 11, channel 51, channel 50, 49, 31, and some other channel. So you got 6 transmitters running all different frequencies. If you can turn around and simulcast them on one frequency, you free up 5 other frequencies. So amateur radio, instead of me turning around and saying, well, I want to put a repeater up north, I want to put a repeater there, I want to put a repeater elsewhere, and link them, these are the latest old linking. This company's out of business. One of the problems is technology changes, but this now you would do this with a Raspberry Pi, most likely, but you have to burn an image, you have to install the software and stuff. This, you just hook them up, tell them who they're going to connect to. I can connect 2 repeaters with this through the internet, and they'll talk to each other, but they're going to be on 2 frequencies. So I'm using up 2 frequencies, so that means somebody else can't put up a repeater. So with simulcast, you turn around, you put up a bunch of repeaters, they're all on the same frequency, you're driving along in a vehicle, you never touch the radio. You just drive and drive and drive. You drive from Boston to Canada and never touch the radio, and you can talk to a person. You can move through areas. Most of the time it'll work really well. Sometimes there's a little idiosyncrasies. See, technology will, when it does work, when you set it up correctly, it works great. Okay, next. So in this case, I got here. Okay. I didn't do many pictures. So in this case, the mobile's right in the middle. Here's the receiving site. It's also going over to the other 2 sites. All 3 sites are going to bring that audio, the received audio, back to a server at a central location. And as they leave those sites, it's going to turn around and get a signal level. I think it's an RST or something. I forget now. But there's going to be a little signal strength stamp put onto that audio, along with a time stamp. Time's important because you need to know how much to delay your audio by. So as that vehicle drives through, if it was here, it would reach this one first, and it would reach this one, but since it's closer to there, it's going to say, go to site 1. We're going to use that audio, and we're going to send it out to all the sites. As you're moving through, it might switch several times. That's where it sometimes gets a little bit nastier, but if everything's timed up correctly, it should work correctly. You can go to the next one. So that's just, so that's just a bigger view. So yeah, the central voter. This is all called voting. Voting for who's the best signal. And in the case where that vehicle is, it's site number 2. It's going to send site number 2's audio to site number 1 and site number 2. Everybody gets the same audio. Okay, next. While driving through in the transmit section, FM, you may not know, whatever. I'll bring it up. So FM works through capture ratio. So whoever's the strongest signal is what the radio is going to receive. There are a few times that the signal will be at a certain point that you'll actually will be able to hear the other signal. You'll hear that once in a while when somebody keys up on the repeater. Same time, you may hear a little brrr. That's because the 2 frequencies are not synchronized. They're at different levels. So as this vehicle's driving along, the transmitters will just being received. Same audio is being transmitted to all three sites. This vehicle's driving along. He's closest to here, and this one's transmitting the same thing as this is, but he's closer to here. So the capture ratio is basically going to work off of site one. As he starts to get to the middle point between the two, and plus with terrain and all these other things can come in, but this is a city type scenario. When he's right there, both signals are going to be coming in basically, we'll say equally. And those signals have to be in phase. If they're out of phase, it's going to reduce your signal. We'll go over that real quickly. I'm not going any technical things on this. It's just like a bird's eye view. So the important thing is to keep those frequencies the same. The only problem is there is a little idiosyncrasy. If you're driving on the highway, you get Doppler effect. So you may have all of your transmitters standing still, perfectly synchronized, but that Doppler effect is going to come into effect. But it's usually small enough not to cause a problem. Next one. And so basically it's just showing that as he's driving through, he's now on site 2, and he's also receiving site 3 because that's close, but site 1 is far enough away that it's out of the picture as far as capture ratio goes. It's history. It doesn't exist. Okay. So in this case, basically these guys here could never talk to these guys here because of the two mountains in between. And this poor guy in the middle of the valley or whatever, he's going to be hearing everything from there and there. And when he transmits, it's going to go figure out which receiver is the best. It's going to bring it in, and it's going to retransmit it to every transmitter identically. Basically, one of the things it has to do in the audio is you have to take your furthest transmitter out. That's your delay factor. The closer ones in are not delayed as much. So you need to delay the closer in transmitters so that everybody's in time when it comes to audio. So you have to time your audio, you have to time your RF. So with simulcast, it makes a beautiful system. You can turn around and basically go through the mountains and everything and never touch anything and be able to just talk. There is a simulcast system, I think, on 2 meters in Maine. There is a UHF simulcast system, possibly in Vermont. Some parts of Vermont, I'm not sure where, but they've been working on that too. So there are simulcast systems out there. It takes a lot of equipment to do it, and there's a lot of money. Okay, next, because I don't even remember what's anything here. Here's we are. So on the phasing. So my drawings aren't perfect, so I'm sorry. So basically, in theory, we've got a time period here, and transmitter 1 and transmitter 2, they're both in phase. So when you have a 4-watt signal, a 4-watt signal is like a power amplifier. They're in phase. You're going to get basically 8 watts out. If they're a little out of phase, then you're going to be subtracting. So down here, we got it where it's 180, whatever, out of phase. So on the positive peak here, we have the forward, but at the same time period, it's on the negative cycle, the -4. So you add the two together, you got 0. So when you have in simulcasting, you have 2 zones, 2 transmitters transmitting at the same time, and they have overlapping zones. And where they overlap, if you have a bad area, normally having the 2 transmitters synchronized, they can actually add together to give you a better signal in that lower signal area. It can also subtract from the signal if it's out of phase, if things aren't exactly right. Okay. Yeah, I know you guys are waiting for this. Okay, go ahead. So that's the actual whip that's up there. As I said, it's on a 10-foot Schedule 40 pipe, and the antenna is 21.5 feet tall. Go ahead. Multiple pictures of the whip just to show it's on the roof of the building, okay? Further back, just showing the situation. They're actually putting ribbon razor wire along the rooftop, which if they do all of that, I can never go up there if I wanted to. I'm not sure if they've been having vandalism or something going on up there. Okay, next. Just a little bit further back, the shelter where all the two-way radio is where my Jeep is. Next. fence has been taking a beating. It's just all the same antennas. Keep on. Next. Same deal, just different views. Just showing that there was the wind blowing. Of course, the antenna's straight there. When I put the antenna up, I did take a level and make sure it was 0 and 0 degrees. Make sure it was perfectly straight up and down. That from the other side, the antenna's over on the other side. The tower is a huge tower. Fort isn't exactly super duper high because if you notice right over here, it's actually coming up to the level. So there is some shadowing going, might be occurring close in on the other side of that hill. Next. I should have figured out when I took these pictures, I had no plans on actually using them. Go ahead, next. Next. As you can see, there's a lot of New Hampshire. It's full of hills. If 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 you had Fort Mountain down in Massachusetts, it would be like Mount Tom, basically. Mount Tom works great because it's the highest thing in Massachusetts. Is pretty level. Next. The trees are starting to grow up. I can remember when I could just see everything perfectly, but now all the stuff's again hard to get a view because the trees are growing in. This was in October, so that's kind of southwest. The sun is not up to the north. Next. That's looking to the north. Next. I'm sure it's not. There's a lot of antennas mounted. I'm not sure if it's straight or not, but there are other antennas that are actually leaning one way or the other. And if we go back to the wind effect, one place is going to work great, the other place isn't going to work great. And I'm going to bring into just thinking about it. So on Mount Washington, the highest place here, you would not want to put a 9 dB gain antenna up on top of Mount Washington. Mount Washington is so high, it's just going to send that signal out way out, and it's not going to be able to get enough signal downward. You want to use a broad pattern antenna to get down into those valleys close by and stuff like that. I actually, Channel 11 was going to put a TV transmitter up there, and they, because electricity cost $3.95 at the time, I think it was $3.95 a kilowatt hour. A TV transmitter would be very expensive to run, and the original engineer designed the system to have like a 12 dB gain antenna up there. I sat there saying, "What are you guys looking to do? Serve Canada, New York? What are you trying to get?" So I redesigned it to be a low gain antenna, well, a certain gain antenna with lots of negative beam tilt to force it downward. And unfortunately, we never actually built it because it was going to cost too much. Yes. Reception wise, yes. In theory, it would because your antenna, if you have a 9 dB gain antenna, the 9 dB gain antenna is going to help your receiving ability because it's going to, like in a parabolic dish, you're going to take all that broad stuff, the small stuff that's coming in, hitting the dish across the big panel, and then being focused out to the focal point. And now it's a big energy, and you're able to amplify that and actually get a satellite dish or whatever. So with the more gain, as far as I know, the better the receive. That's why going back to my scenario of using a low gain antenna and in putting a 400 watt transmitter repeater, 400 watt repeater. So right now we're doing 400 watts ERP, effective radiated power. And I decided to put a no gain antenna up there, put 400 watts into it to get the same distance that I'm getting with a 9 dB gain antenna. The problem is going to be is the guy that's out there at where that signal's going, I don't have an antenna to amplify or pick up that signal as well because there's no gain to help amplify that part coming in. So it would be detrimental. I would be all talk and no ears. So basically, I've tried to balance it that where you can talk back from, definitely with a mobile, is where you're going to hear it. When you start to hear that repeater going down, your signal in theory is probably going down into the repeater. Now, when I added the gas fed, it helped the mobile some. And the handhelds, now we've got, people with handhelds down in Massachusetts talking into it, and on a regular basis. They're not great. Sometimes I want to say, just go get a mobile antenna, because trying to talk to somebody that's fading in and out. If it's a calm day, they're always pretty much consistent in there. If they move it back and forth, they're going to change their pattern also. And the handhelds, depending on what you got, it's funny. This is, as you get into the dual band, this is this is a dual band UHF VHF. And this is strictly UHF. And wow, this is 900 megahertz. And the 900 megahertz antenna is almost as tall as the dual band and is longer than the UHF. My guess is, and I'm going to say guess, that this antenna here has more gain than this antenna here. And because this is a dual band antenna, it has to be longer. There's a compromise. I'm assuming there's probably a trap in there, but so basically one part is UHF, which would be down here, and then the trap opens up for the VHF part, and it becomes the whole antenna on the top. I could be wrong. I don't know. So okay. So I zoomed in. That's to the north. I'm thinking the closer mountain in is Mount Washington, but I can't remember, or is it the one that's further? I noticed there's a tower. I can see a tower on top of it. I was trying to get Mount Washington. Okay, next. I think that was just a different. I think that's Mount Washington. I think that one. And so that's it. But you're going to have to look at my shack, my HF shack now, because I did this. So go ahead. So I just ended up building this. This has been my project for the past month. I built this all out of Unistrut. I haven't finished it yet. You can actually see the Unistrut up here. I 3D printed all the covers and everything to go over the Unistrut, so it made it nice and pretty so that you don't see that ugly Unistrut. Put my LED lighting. My HF transmitter is a 1962 T368. It weighs about 800 pounds. I'm not going to be able to work on it soon. I did do its final cleaning last year, I think it was, but hey, maybe I got another year or two. So I do AM on HF mostly. So when I'm on AM and at the shack, the R390A and the T368 are my babies. When I'm running remotely, I have the Flex, which allows me remote operation. The Flex is a very good radio. It sounds great on AM, sounds great on a sideband. I guess it works well on every single thing. And of course, I had to put, when I was a teenager, my CB, which is the D201, up there. I actually had sold mine, and I found one on eBay cheap. I don't know if it works, but that's, I just had to put it in there because it brought back a lot of memories of stuff. And my Drake equipment, that also a lot of memories. I hope to eventually get this UV3. It actually works. I did turn it on. It received Fort Mountain. I just wire a microphone, and I have to put a tone encoder on it and get it working. You can go next. That's actually, so the blue one's a Turner Plus 2. And for whatever reason, I bought this TR7. Somebody was selling a TR7, and they had a Noble VFO, DDS VFO. It has a speech processor. So the guy said that he goes, I'm going to give you the Turner Plus 2 because it works great on sideband with this setup. I've never gone on the air with it. It's just, it's one of those things that, memories. I mean, I had an L4B. My parents wanted all my ham stuff out of the house. This is when I was young, and I sold it at Deerfield. And then after that, I immediately regretted selling it. So then I had to get one back. Then I had to get 2, 3, 4. No, whatever. It's just, so you go to the next one. I also have an old teletype from 1942. It actually works. I love that teletype unit because back in the 30s, it was the first computer. In theory, it's Baudit code. It's Baudit 5, if I remember, but I could be wrong again. So I plan to get that running again. It actually works. It's just a matter of that I have to get it interfaced. And go ahead. That's just simply, I'm just showing from the ground. I've actually used Unistrut down on the bottom to hold all the power supplies for the TR7, the L7, and the L4, and go ahead. And that's just the close-up view of the equipment, and go ahead. Nothing really special. And so that's, I hope it was worth your time. I don't know. It's, I do have, eventually, I do have my W1ASS, which I will be probably posting things about upcoming stuff. I will quickly go over some things here. So I'm really going to drag it out just for a few seconds more, few minutes more. I'm also, because eBay has been charging such horrendous prices and things like that, I'm actually developing it. It's actually, it's there, but it's not done. And I should take it, I shouldn't have it there where you can get to it. But it's going to be a auction site that's specifically for amateur radio. So every category is amateur radio based, whether it's Drake, Collins, whatever. You go in there, there's virtually no fees on it. I'm just going to go to the simulcast real quick. So I started I had this dream of simulcast many years ago. And so I ended up doing a voter board. And so this is the board that goes to the repeater, and it talks back through the Ethernet jack back to the server, puts all the stamps on it, the timestamp and everything on it. But there's a little problem with this design that was done by Ham. There's a crystal here that's a 9.6 megahertz crystal, which is very unusual for clock oscillators. For the processor, it drifts. And because it drifts, that controls your audio and the delays. And since it's drifting, your audio won't stay locked exactly. So it became a problem. So the cure was to build a PLL synthesizer. So I got these boards made at China, cheap, and it required these symmetric, whatever. This is a high stability oscillator. Goes on the board. Got some PLL chips. This generates a 9.6 megahertz frequency that's locked to a GPS. It has a GPS input on it. It locks this oscillator, so you get your 9.6 and it doesn't drift. Well, that was great, but now you can't get these crystals anymore. So I have 2. My plans, I had 5 boards, I believe. I have 5 of these, and then it came out to this little box actually does all of this. And if I remember correctly, it corrected this problem. So I can get rid of that, I can get rid of that, and I could just use this. This is expensive. I don't remember how much it costs, but I want to say it's over $200. It may be $300 now. So that kind of drives me back to, well, I already own 1 of these, so okay. But I own 5 of these, so, and then I have 2 of these, and I did buy all the parts at DigiKey to stuff the board with, so maybe that'll be the project. I don't know if anybody here, Linux, really good Linux people? No? Ah. Okay, so when it comes time that if I ever actually do this, I may be looking for people that, because it's asterisk, it's asterisk based, it's Linux. Linux is the OS, and you're using asterisk, which is a voice over IP system modified for voting and simulcast. Another thing on your repeaters, if you ever decide, it's actually even good on the home, but these are very expensive. They're polyphasers. They're lightning arresters. These are the commercial version. I don't skimp on this because I'm not going to buy an amateur radio spark gap lightning arrestor. You don't know when they're going to go. These things last. These all toss. They're expensive. They're 100, $150, $250 for them. But when you have a $2,000 repeater, that's your insurance policy. The going to go to the revealing of the history of Fort Mountain. I didn't want to have it exposed because everybody be looking at it and not looking at me. Ah, so let's see here. So we have here on the top of this repeater, which is a Quantar, which is identical. So if I was going to do a true simulcast system, you have to have the same repeaters. Your audio circuits have to be the same. Your exciters, your audio paths, everything has to be the same in order to get the ability to get everything synchronized. So here we are, a GPS receiver. Of course, this is old technology. I have to have one of those at every single site if I do it. There was another thing that I left off. Miraculously, in addition to this board here needing the special 9.6 megahertz crystal that requires the other board, well, I found this made in England. Leo Bodner, he makes them for SDR radios. This uses a GPS, and you can set it for any output from 1 hertz up to a gigahertz of what you want, and it's GPS disciplined, so the accuracy of this is very good. So I can set this for 9.6 megahertz and turn around and insert it in place of the crystal that's on this board. $153, however. Although I found to buy one of these crystals is about $100 if you can find one. So they're getting you for that. So now the GPS receivers are this big compared to that. It's just technology has changed. Antennas haven't changed. That's just standard GPS antenna that you have to put at every site. This one is fine. I've actually used it inside the house and on the windowsill. It supposedly is outdoor rated. I don't know, but that's what I would have to use. So then over here, so you had the picture that you saw of the first. You can look at it later, which is the first. It's actually version 2 of repeater Fort Mountain. Version 3 is a tape repeater. That was the best working repeater, I think, for coverage and everything. I still think it worked better than the Quantar, but I could be wrong. It's made in New Zealand, required an external controller. Let's see here. So it's actually active. I'm going to end up keying up Fort and this one at the same time. So that the reason I was saying that's an expensive one. It's got an actual real-time clock that I ended up buying separately because every time the power went off, it lost its time. The clock drifted because it relied upon the crystal that was in the unit for the CPU to derive its clocking time. And I added audio delay boards, which delays the audio a little so that it can clip the squelch tail. So you end up getting, so the famous, which everybody hates.
Time is 8:47 p.m. Welcome to the W1ASS 440 repeater.
And so that was the setup before I went to the Quantar that everybody wanted digital. No sooner did I put up the Quantar P25 and people told me, oh, why don't you put up DMR? Why don't you go put up DMR? I just bought this one. And now you're telling me, yeah, but P25's commercial, whatever. That's what's staying because it cost me a lot of money to buy that repeater, to bring the digital along. Finally, let's see here. Is that everything here? Yeah. Finally, a lot of people have said, well, why don't you put a hotspot or whatever you want to call it? Why don't you link it into the World Wide Web? My only linking that I do is RF linking. All my 900 repeaters, which I'm going to tell everybody, do not invest in 900 at this time. People will tell you, oh, you should look at 900. So I have 3 900 repeaters. That's up on Goffstown. I have one over in Deerfield, and I have one down in Georgetown, Mass. They were all linked together. So if you key up Georgetown, Mass, it keys up Goffstown. So you could talk down to Boston, to Manchester or surrounding areas. So for Nearfest, in theory, if I had them linked up, they'd be able to drive from Boston all the way to Nearfest and talk on 900. Unfortunately, 900 megahertz is potentially going to go away. There's a land grab for the frequency, and I don't think it's going to fare well. So I'm not putting any time in 900 now because of that. I could fix the linking, but if I do that and then 3 months later it's shut down, I wasted all my time fixing all the linking, putting in new equipment, and so on. So other than that, I want to thank everybody, and I want to thank all the users, everybody that uses the repeater. Great group, very cordial. It's something that I want. I will very quickly say that when I did first get my ham license, just because I was curious about it, but I was already in the broadcasting field, I got on a repeater. I've told many people here about it, but I got on a repeater on Goffstown, and I forget what I was talking about, but I mentioned it, whether it was about the deer, the sky, the moon, the stars, whatever. A guy came back and jumped on me and read me a riot act about proper use of repeaters and subject material and stuff like that. And it can only be about two-way, it can only be about amateur radio, it can only be about this, it can only be about that. Very narrow, very definitive. Well, it's his right, it's his repeater. He can do whatever he wants. I said to him, I'm very sorry, I didn't know, I'm really sorry, I will never do it again. Well, I'll never do it again. I got home, I deleted that repeater. It's gone. So no way. There was a gentleman came on the repeater a couple months ago who had his ham license for like 20 years. He said he got on the air and he was so discouraged from how he was treated on a repeater that he put the radio in a closet and never got back. And then somebody mentioned to him about Fort Mountain or something. So he turned around, pulled the radio out, programmed it up for Fort Mountain, said, wow, I wish I knew this repeater existed before. The group of people, everybody, it just makes it ring. So I want to keep it that way. I hope that everybody uses it. It's very welcoming. If somebody's making a mistake or they don't know, kindly tell them what they don't know. We're not everybody knows everything. I know nothing. It's just not right to jump on the people. It's just going to scare people away. The hobby's never going to grow. It seems that the hobby is growing just here. I mean, your club here is growing because of people on Fort, maybe. It's introducing people to the fact they hear about GSRA and, oh, I'm interested in joining. So it just works out for everybody. So I want to thank everybody for being the way that you are, being on the repeater. I think everybody's great on there. And what? Yeah, Epsom. Yeah, actually in Epsom. Um, some people think Deerfield. I mean, you can see it, you can look over to Pembroke or over to Deerfield. I can see Saddleback Mountain. From Saddleback, I can make a shot straight over with a link if I wanted to. So that's pretty much it. That's just all the equipment that was ever at Fort Mountain. There's the actual duplexer that was there this winter, which was the big debate of the buzzsaw. The buzzsaw, if you do a YouTube search, Quantar Roar or something like that, you'll find out that there's a lot of, down in Florida, some ham clubs, they're all experiencing the same problem. It seems to be, it's something with certain model radios that happens. I'm guessing that's why they discontinued that line. They moved on to the MTR, whatever it is they've gone to. I don't keep up on that stuff anymore. It's too much for me. But it's just the fact of the repeater. And so that duplexer got changed out. And unfortunately, I had to make the decision. I was down in Brazil, and the price was $550 used. So I ended up spending. No, the buzzsaw has nothing to do with the duplexer. But that duplexer has bad cables. There's something amiss with it because I remembered if you touched it a certain way, it started screwing up. So now it has another duplexer in it, and that duplexer isn't going to screw up. So that's it. Now, if the antenna breaks, you will see a GoFundMe because I don't know what it's going to cost wholesale. I can get it most likely for wholesale, and unfortunately, Antenna Specialist no longer makes the antenna. They got bought by the other company who got bought by whatever. And I noticed it's not quite as long and not as heavy. There seems to be some spec differences. So I think they probably, I hope they didn't send it to China to get it made, but I don't know where they make it, but I hope it's made here. What's that? Oh yeah. You know, I mean, unfortunately, the Chinese stuff, it works or whatever, but it may work, it may not work as well. Motorola's going to break, Yaesu's going to break. I mean, every one of these brands, you're going to find something wrong with them. It's just sometimes I think the Chinese tend to, all the components are rated at right at the borderline of maximum rating. So if it's a little too hot and you key that transmitter up too long, you've really exceeded the rating of that component and you've blown it. So thank you very much. Thanks.